and then 10 to 3 is the kilo, and then 10 to 6 is the mega, and then 10 to 9 that was giga. So in this exam, I never ask you what is the giga, mega, kilo, milli, but this is really the basic. It's the really few students, like 20% is still the mistake. So this is why, just double check. It's very important, okay? All right. So from the chapter 2, we learned before the active power, reactive power, and apparent power, right? So here, this is the last time to remind of you, okay? The S is the apparent power. The unit is VA. If V and I are the complex, means the AC voltage and AC current, okay? The AC voltage and AC current. This is the VI, the conjugate, okay? There's only one reason I write down in the board, because I should make 100% to make the questions for about the S is equal to VI conjugate. A lot of students has mistake, V, for example, 3, 30 degree, the I, 10, 50 degree. So a lot of students, I'm gonna maybe ask you, what is the apparent power? A lot of students has mistake like this one, as VI, 3, 30 times 10, the 15. So they have 30 and 30 plus the 50. This is wrong. Why? Because that should be conjugate, okay? All right? That should be the conjugate, means that should be minus here. So finally, that was the 30 and 30 degree minus 50 degree, and 30 minus the 20 degree here. Okay. All right. Any questions? All right. So we can make a rewriting reformat for the apparent power, means like this one. So the S, oops, that was not writing. Okay. S sub APP and theta. Okay. Oops. And then that was P plus JQ. Please don't missing the unit, okay? Watts, VA, voltage, and that's very important. So that one is the polar form for apparent power, and the other one is complex form, okay? That was complex form. So P is watts and Q is VAR. So one more time, don't missing the unit, okay? And then, hey, professor, what is the S of APP? That is only amplitude. So for example, this is a triangular mass right there. Should be 9 degrees. For this case, or the Q value. And this is P. The P is what? The active power, the real power sometime. And Q is the reactive power and VAR. And then that slope right there. That slope, that is for the S sub APP. Okay, so it means from this circuit, that should be the angle. Okay, again, when I will grade, I'm gonna using the Casio, the calculator. So maybe I know that some of them still using the Texas instrument, a little bit slightly much different. So usually in my grading, the solution slightly but different, but difference is like 2, 3, 5 plus minus. It doesn't matter, but it's like procedure is very important. You understand? So just right there, the theta. Just be careful. So the theta, and then the P is, the S of APP. We can by using triangular methods like P square, plus the Q square. Okay. All right. Okay. Any questions? So maybe it depends on the maybe active or reactive, the power we learned before. The positive, the P, we can draw the triangular method on the right side, just right there, maybe angle. But sometimes from the zero to zero, this is a reference, the starting point. Sometimes the minus, the negative P, we should draw to the left, like this, but should be the same, the amplitude, okay? And also Q is the same thing. Q is reactive power. The observe, sometimes the circuit or device is considered to be the positive, mean this upward, just like this one. The upward, for example, 200 VAR, 100 VAR, 50 VAR, you have to draw the upward, okay? So from the questions, I might be able to ask you, hey, what is the P? What is the Q? What is maybe S? And then please draw the triangular, the drawing. You have to draw. It depends on the P or Q value. You can upward and downward. So usually I might give you really the sample. The P usually should be the positive, but sometimes Q, upward, the plus, sometimes negative, the downwards, okay? So, just like this one. So that is what I wanted to do. It's really clear from the questions. Okay. Any questions? Okay. So the topic 3. So hey, professor, how can we calculate PQS from the AC circuit? Okay, now I'm gonna give you write this one. This is the AC voltage sources, and that is resistor, that is the inductor, and that is the capacitor. Okay, now from the sources, we're gonna assume that that is the AC circuit. So it means V sub S, okay, V sub S, V sub RMS is 0. Okay, so this is R, this is the X sub L, this is X sub C. The R is equal to what? The X sub R, right? The X sub R. So from here, this is the in the series circuit. All the components is really basic 3 elements connect to in the series of the AC circuit, right? So now this is plus, this is minus. Now like this one, okay? We're gonna call it, this is the I sub T. So okay, now I might be able to ask you from the questions, what is the P and what is like Q X sub L and Q and X sub C? Okay. All right. So the first over, to find P Q sub X sub L and Q sub X sub C, you have to know about what is the total the impedance, because if we wanted to find the I sub T, we have to know right there. I'm gonna writing for you here. Okay. I sub T is the total voltage sources, the supply voltage, the AC voltage of V sub S, the divided, and G sub T. Okay, now we have already know from the circuit V sub S. So how can we find, how can we find the G sub T? Now, from the circuit, the G sub T is the X sub R plus J X sub L minus J sub X sub C. Okay, J sub X sub L minus X sub C. So that was rewriting J X sub L minus the X sub C. Okay. I mean, hey, professor, do we keep using the complex form or polar form? It's up to you. But usually, to the easy, effectively calculated, we're gonna using the polar form. It's really better to numerator, denominator, the format. So right there, here, they go to the G sub C. And finally, after we find the I sub T, the question 1, what is the P? The P is the only applied to register. One more time, the P is only applied to the register. So maybe I sub T square times R, okay? And then what is the Q sub X sub L? Same thing, the I sub T square, the X sub L, okay? For example, from the questions, if I give you the only L, you have to make a transformations from L to the X sub L. How? 2 pi FL, that is for X sub L. Okay, 2 pi FL is equal to X sub L. Maybe that. How about the C? That was 1 over 2 pi FC. So it's a really basic advice. If you have the calculator, please be familiar with your calculator. So from my calculator, Casio, there are a lot of really good, a lot of functions. Simplify. For example, if I have the any polar form, complex form, you can just 5 seconds get the answer. But if you don't know the function way, you have every step you have to calculate. It's a really long time. It means really inefficiency, means high potential to get the risk. Okay, Dylan? Okay. So now the last one is, what is the Q sub X sub C? Same thing. Why? Because the I sub X sub L, I sub X sub C in the series AC circuit, same thing, like this one. Okay, that was very important for the second exam or your future work in here, right? Any questions? Okay, I think so. Okay. All right. So maybe I'm gonna skip the sample question. Okay, this is the when you go back your home, you can practice yourself. Okay, but I wanted to point out. All right. So now I wanted to explain about let's say the power factor. Okay, the topic is power factor. The power factor is the ratio of the P over S. Usually S is not the officially form. It's like S means S apparent. Maybe S apparent like this one. So it means unit watts over VA. Watts over VA. Okay. So when you go to any company or any industrial institute, you might have to know see that about the power factor, because any system performance we can check from the power factor. Means like what is the power from the demand power. Okay, some of them usefulness, some of them the useful active power, usefulness reactive power. Okay, so this is why. And then that was also, we can calculate it, the cosine theta. At this point, a lot of students has mistake. Professor, what is the theta? This theta, do you remember in the previous one, I have draw, right, this one, this is theta, okay? This is P, this is Q, this is S of APP, right? So from the triangular, we're gonna see that this is my theta. So the cosine theta means S of APP over P, this is, cosine sine. This is really trigonometric, really the simple math. So sometime I'm going to ask you, if you know P and S of APP, the theta is the cosine P over S of APP. Okay. That is my approach here. Okay. That is my approach here. All right. Okay. Okay. Any questions? Okay. The one more things, usually, how can I say? It depends on the theta value, like this one. Theta value for the pure resistance, the theta is like 0. What does that mean? The Q, it's the 0. Okay, and for pure, the inductance means X of L or L. Theta is the 90 degree. Theta is the 90 degree. Means Q is the upward. Okay, like this one here. But for, oops, I'm sorry, for a capacitor, kind of C or the X of C, oops, the theta is the minus 9 degree. Oh, I'm sorry. Theta is the minus 90 degree. So it means the Q is the downward. Oops, like this one here. Okay, like this one. This is the Q. This is the minus value S of APP and P. Okay. Yes, definitely. We're gonna assume that the P is the positive value. Okay, that is what we wanted to do. So that was for really basic concept for the power factor. Now, so the another topic for chapter 2 that we're gonna learn about the two different the rod. The one is the inductive rod, the other one is like capacitivity rod. I think if you have my printout, the page, the 21s, this is the very important. I might be one of the questions to ask you maybe after you analyze the circuit. That is for the power factor is leading or lagging. So usually the power factor leading is mean the current lead voltage. Okay, means Q is negative. Okay, this is the S of APP. Theta is like this less than the 0. So that is usually the capacitive load. Very important. Okay. Okay. Maybe in the review class, as I said before, very important. Only one reason. Okay. At least the 90% I can make a questions. Maybe any circuit you have to calculate it to find the Q. It depends on the Q. You have to recognize, oh, the Q is the minus 300, the VAR means I lead voltage and power factor is the leading, and that is the capacitivity load, okay? But the power factor, usually the lagging, that is the inductivity rod, means V lead I, and Q is the upward. This is the S of APP, P, and the Q, okay? So the one more time, from the Q value, you have to writing in the answer sheet of the exam. That is I lead B, a V, or V lead I, or power factor leading and lagging. You can classify. Hey, professor, how can we know about this one? So it depends on the Q value. It depends on lead, V and I relationship. For example, you can see only I and V value. You can classify V lead I lead V, okay? So maybe I lead V, the power factor should be leading, means that is capacitivity load. And Q, the downward, you can draw. I think the quiz and in the first exam, maybe I think you can see very similar questions. I think we have also similar questions from the printout, you know, something like that. I do not want to more the tricky. It's really the same or similar question. Yeah. And also, you can see my printout, the page 22. Maybe for this the 2Ks, just only for the inductor and register. Oh, I'm sorry. This is not the inductor. That was the capacitor. And the other one is the inductor and register. Just only the two elements with the register. However, if you see the capacitor, the inductor, and register, so how can we classify, you know, the leading power factor or lagging power factor? So from the circuit, you can calculate it, the X sub L and X sub C. I'm sorry, this is really not clear. So maybe the Q sub L is greater than the Q sub X sub C. You know, that power factor, power triangular, the power factor is like the lagging, okay? But however, Q sub X sub L less than Q sub X sub C, the power factor is the leading, okay? That is what you have to do. So maybe the one more time, from the maybe AC circuit, which include the three basic elements, you have to calculate it, the Q sub X sub L and Q sub X sub C here. So maybe after you find I sub T square X sub C, Q sub X sub C, and I sub T square on X sub L, that is the Q sub X sub L. So it depends on, for example, 300 VAR, that is the 200 VAR, that was the power factor is the lagging, okay? The power factor is the lagging mean the voltage lead the current. Yeah, that is the inductivity, the rod. Okay, that is the, you know, it's all we have long before from the quiz, from the lab reports, and I have a lot of time to look it again in the class. You can go to the 22, the page, and 21. You can check what's going on. Okay. All right. So that is what I have, and a lot of sample questions you have to study before. Okay, when you go back to your home. All right. So what time is it? Okay. So we have the two more topic. The two more topic is the power factor corrections. Okay. The one more time. The power factor corrections to improve the power quality, the after adding to the capacitor are in parallel. Why do we have to adding or in parallel of the AC register and inductor circuit? Because after we cancel out means to the same value like this one. I'm gonna show you here. Okay. Honestly, the 90% I will make questions for power factor corrections. So please be carefully read the study from your lab reports and quiz and not quiz, yes, quiz. Yeah, quiz questions and then the sample questions from the lecture. Please read it very carefully. And if you have any questions, please let me know. This is maybe R, and this is maybe X sub L, and this is the X sub C. And then that was V sub S. So again, in the power system courses, all voltage sources is the root mean square. So you don't need too much change from the RMS to the peak or peak to the maybe RMS. You don't need it. Or value, I assume that the RMS, you have to just calculate it. Don't worry about that. Just assume that. So just right there. So finally, we have to find the C. Why? Because after adding or in parallel in the AC circuit consists of the R and L. So after adding the capacitor, Q sub X sub L and Q sub X sub C right there. Okay, the Q sub X sub L is equal to Q sub X sub C. We can cancel out reactive power. Means real power, useful power is increased. It's more is good. So maybe after adding the capacitor to cancel out means the power factor is almost is 1. Okay, why is real? I mean, in the real case, it's impossible. But you know, theoretically, from academical, you know, in this class, we're gonna looking for the C. So if you wanted to find the C, the first over, you have to find the X of C. What does that mean? The X of C is the reactance of the capacitor, right? The conductor, right? So the X of C, the unit is ohm. That was 1 over 2 pi FC. So if you will find the X of C, C is 1 over 2 pi f X of C. Okay. So finally, you can find the C. And then don't missing the unit, okay? That was the Faraday. So usually microfaraday, okay? So the first number, you have to find the Q sub X sub L. And then the Q sub X sub L should be the Q sub X of C. The Q sub X of C is what? The I square. No, okay. This is the, oh, I'm gonna write it for you. The another color. So right there, this is the V sub S, and that was also V sub S. Okay, so the Q sub X of C here, V sub S squared over X of C. That is equal to Q sub X of L. Hey, professor, how can we find Q sub X of L? It's the simple issue. Q sub X of L is I sub T squared X of L. So to keep in mind, Q sub X of C and Q sub X of L has different equations. A lot of students has mistake. I have 3-time power system courses. Every time, so maybe if you do not the confusing the right approach here, well, you're gonna A. Maybe almost students from my previous class, if you can solve the right equations, usually the student who solve these questions with the right equations, that student's almost A. But some students has the mistake like this one. Maybe I'm gonna show you. The Q sub X of C, a lot of students has the mistake I sub T squared the X of C. No. Why? Because that was the I sub T. Well, this is not I sub T. That one is I sub T minus I sub R. More complex. So I recommend just only the V sub S. You can calculate it to find this one, okay? All right, any questions? Okay, so the last topic for today class, okay? Just 5 or 10 minutes. After that, have a good lunch, okay? So the last one, okay. Okay, why? Oh, I'm gonna the attendance to the sign sheet. I'm sorry about that. Yeah. Oh, you have already done. Yeah. So where is the sign sheet? Connolly, do you have the sign sheet forward? Oh, Steve. Steve. Okay. So I'm gonna record video because the Hollies or the white, I think it's kind of the family or issue. So this is why. But the as I said before, the maximum the 3 times the before class begin, hey professor, I'm gonna sick or family issue, I cannot attend the class. The 3 times the waiver, okay? As I said before, don't worry about that. All right. So the last was the topic for this is the 7th. I'm gonna share with you. So load and the generator, the convention. That is also very important. Okay. I 100% said to you 100% very important. Very important means I have only one reasons. Okay. I will make a questions for that topic. Load and generator the conventions. From the question, the page the 33. Okay. Yes, sir. A load and generator the conventions. So the page the 33. Okay. Okay. The last page, I think, from the presentations. Okay. So what do you remember? That was the that is any device, any argument. This is the plus, and then that was the minus. Okay, that is the plus, and that is the minus. The current, plus to the minus. The enter in device is the current. What we're gonna call as that is the load convention. Okay, this is the load conventions, and also in the power systems, and plus minus the voltage here. We're gonna call as the out, the leaving the current. That was we're gonna call as the generator, the conventions. Okay. So one more time, the load convention, the current, the enter, the positive terminal of the circuit elements. I'm gonna writing for you. The current, the enters, the positive, the terminal of the circuit and elements. But however, the generator conventions, the current leaves from the positive, the terminal. Positive terminal means, you can see that right there. This is one is the plus, the other one for it is like the minus. So I leave from the positive, the terminal of the circuit elements. So it depends on currents, the maybe entering or leaving